Hi, everyone. This is Gary Berman, host of the Cyber Hero Adventure Show, and we have a very special edition today with our guest, Herb Roitblat, who has been a mentor of mine, and also, if you allow me, Herb, to call you a friend. And Herb is the author of an amazing book called Algorithms Are Not Enough. And this book came out several years ago. Herb, welcome to the show.
Thank you, Gary. And friend is the one I'm sure of. Mentor is one I don't know. I don't know if I deserve that.
Well, I appreciate your humility. When did you write the book again? Refresh my memory.
Oh, it came out just at the start of COVID in 2020.
So, for our audience to provide context, Herb is ahead of the curve on most things regarding AI. And this is something that my audience knows about our mission as well, the nexus of AI and cybersecurity and all its impacts. And that's why my background is blurred. So it's a subtle nod to an evolution of our mission. And we've been leaning heavily into AI now for a little over 2.5 years. And so, Herb, I just wanted to catch up with you because I remember your book and it was pretty amazing. And but for our audience to provide context, what was your main thesis of the book?
Well, the main idea in the book is that you have to know what intelligence is if you want to build it. And just being able to pass tests is not enough to be intelligent. And so what I did is I put together a lot of the stuff that I knew about natural intelligence, the psychology of problem solving, and so on, and put it into the book in an accessible way that people could read it and have a better idea of what they were trying to build. Um, since then, I've started another book that is more scholarly and not and directed at more professionals. And the idea there is to provide what I think people need to know if they're going to work towards artificial general intelligence.
Yeah, and as our audience, I'm sure, is well aware, that's an amorphous definition at the moment. It means different things to different people. The different frontier models all have some slightly different way of thinking about what that is and when we're anticipating reaching it. What is your description of AGI?
It it involves intelligence as a thing. It's not just a label for being able to solve multiple problems. Rather, there is something in cognition that could be accessible to computers. I don't think that it's unique to humans, but it's an ability that is transcendent of the observations of specific problem solving. I think of specific problem solving as attempting to stack hedgehogs, where the idea is that hedgehogs know one thing very well, which is what AI, current models of AI do. And if you stack enough of them in this informal theory, you should get artificial general intelligence. But I don't think that that's true. I think what you need are foxes, where the fox is wise about many things, maybe not as efficient as a hedgehog is, but the fox has intelligence that hedgehogs don't have, and I think that's the future of it. Put simply, I think that artificial general intelligence has to be able to solve the whole range of problems that a human faces, not in the sense of being able to solve any possible problem, but being able to solve problems from start to finish. Right now, most of what the AI models solve is the last step in a long chain of human problem solving. So the humans provide all the input, and the computer model delivers the result. That is not, in my mind, general intelligence. Now, it could be useful, and it is useful. It's a huge breakthrough actually for narrow intelligence. It's important that it can solve many problems that are all solvable by a language model, but it's a language model. It's not a cognition model.
Yeah. Can you amplify that a little bit?
Yeah, so it learns the probability of words given a context of other words. The relationships are the relationships of the probability of words. They're not the relationships of, say, truth or physics or anything else. Some people try to get them to solve math problems, but they treat the numbers in a math problem as if they're words, not as if they're math objects, which is kind of ironic because computers do math better than I do, better than any human does. But we've got them doing language problems and assuming that those language problems will solve math issues, and they don't. That's why they make stupid mistakes.
Yeah, we're going to delve into truth in just a moment, but before we get to that, so uh, yeah, in the written introduction for this piece, I'm going to explain your background, but Herb, you're a renowned data scientist. Your book was published by MIT Press, and so it imbues it with extraordinary credibility on the things that you're talking about. And so one of the things that, if you can help me understand, is this difference again with cognition. How then would you define cognition? Maybe you can use an animal reference like you did before.
Oh, well, the cognition is the foxes, but it's capability of thinking about things. Now, the problem is those words are used in so many different ways that it's hard to know. An example in my book has to do with expertise. If I give you a particular problem to solve, and you're a novice at solving it, you're a student, say, you'll pay attention to the words in the problem. You'll solve it. If it's a river problem, well, you know how to solve river problems. The boat leaves at 9 o'clock and blah, blah, blah. But if it mentions a river, but really is a spring problem, you may not be able to make the connection and treat it and solve it in the right way. An expert has a different way of looking at it. Instead of using the words to describe how they're going to go about solving the problem, they use the concepts that they have extracted from it.
Right. Mhm.
And that's part of what's missing in today's AI models. They use the words, not the concepts. Um, the latest versions have fixed this particular problem because I think somebody figured it out and figured out they need to add it to the training set. But the previous model, if you asked it which weighs more, a pound of feathers or a kilogram of lead, several of the models would have answered they both weigh the same. That a pound, and not recognizing the difference between a pound and a kilogram, but just recognizing the overall frame of the pattern of words. Now, somebody I think has trained on exactly that problem because the current models tend not to make that mistake.
Well, I saw a video recently with the founder of DeepMind, Dennis Hassabis, and he was talking about essentially the evolution of LLMs and in the way that you're describing it, and what his view, and which I'm sure is held by uh, quite a few people, is neural networks. Maybe you can help our audience understand, like, sort of how the brain works. And I know you've done research in this in the past, how the brain works, and then the artificial intelligence brain.
So you're asking what's the relationship between neural networks and artificial
Exactly.
intelligence?
Yes.
Okay. Neural networks are metaphorically related to the brain. That is, the idea is that uh, the brain consists of networks of neurons. And in neural network theory, the computational version of it, each of those neurons takes an input from several other neurons, adds it up, and then based on some equation, calculates an output. And that's a simplification of the way biological neurons work, but it's very helpful. It was a major breakthrough in 1986 or so when a couple of books came out that described how to use neural networks to solve computational problems. Before then, the way that artificial intelligence worked was to have rule-based systems, and somebody had to sit down and write down all the rules, but then the expert system is what it was called, would take some inputs, apply the rules to it, and generate some output. And that was the best we could do at the time. In 1986, they didn't invent neural networks. That was actually done 1947, I think, 48. But they figured out a way to make it popular to explain some of the learning mechanisms that could work to enable these networks to work. So the idea of a computational neural network is a simplification of the brain, and it's metaphorically related. It's not literally how your neurons work. They're much more complicated than that, but it's effective. It does a good job of mapping inputs to outputs.
Right. And so the other thing that Dennis said was that what matters or what's coming next, or in the future, anyways, ill-defined at the moment, is to provide context for these systems to understand like the world, right? And the world, everything about it. And would that be a usable definition of AGI?
Not a definition. It's important, but then people often misunderstand what it means to have a world model. It doesn't mean they've got a map of your neighborhood. It means they know how things are related, not just how words are related one to another, but how the concepts are related one to another. They know that, you can be described as Gary, as Grandpa, as Mr. Berman, and lots of other ways. They all refer to the same person. But the only way that the current models know that it's the same person is because they tend to occur in overlapping contexts. That is, different paragraphs talk about you in different ways, and there's overlap in them sometimes. But if there isn't overlap, then there's no way for the models to learn that. So when he says they need to learn a world model, they need to learn things like object permanence. They need to learn things like so object permanence. That is, when a ball rolls behind a barrier, what comes out on the other side is likely to be a ball, not a box. It's not the same thing if it's a box that comes out. For a baby, that would be surprising. For a neural network model, they would just go ahead and learn that.
Right. Oh my gosh, there's so many things to unpack in what you just said. But one of the things that blew my brain about this is that there was a research paper, I'll just say generally, but that basically looked at language translation, like
Yes.
English to Chinese or whatever. And it turns out, at least according to this paper, that the LLMs actually don't use a language that we understand. They invented their own language, and the actual language was almost immaterial because of the process that it went through. And only at the end does the system overlay the language of Chinese, but everything inside of it is some other language, and it's beyond my pay grade. But
Well, no, I wouldn't say it's some other language. I would say it's some other representation
oh
because
yes, yeah,
it's a
yeah,
neural network inside, which means it's just numbers and things that transform one set of numbers into another set of numbers. And it goes through, and if the statistics support it, if you have enough training examples, you don't need a language, you don't need a theory of language. You need a mapping that says, when you say this, now translate to say that. Early models like that tried to do it word by word by word. Current models use bigger units of text in order to get more of the context in.
Indeed.
And it's still context is still words.
So as we're kind of wrapping up, I know your time is incredibly valuable, and I'm so grateful that you shared it with me and our audience. Um, we tell us about truth. This, we only have a couple minutes, but maybe we can have you back on. But this notion of truth, like, how do we know what's true?
Well, yeah, one of the essential parts of a world model would be to be able to understand things that are true. Now, the current language models, they don't have any representation of truth. They just have a representation of how words relate to other words, just like we were talking about Chinese. So they need something that represents the world that is separate from the probability of language. Here's a sentence. Fatty weighed 300 pounds. So if you say, what did Fatty weigh? The answer is 300 pounds. If we say Fatty weighed 300 pounds of grapes, and you say, what did Fatty weigh? He weighed grapes.
Oh,
But the language model uh, represents those two as being very, very similar to one another. It doesn't distinguish between what gets represented between the two uh, situations because there's so much overlap in the language. So if you want a truth model, the truth model needs to be able to go in and say, what's the difference between those two sentences? And how do we get a true representation of what Fatty weighed? And it's not so much that to distinguish between fake news and real news. That's a potential application, but it's more in the business sense of being able to represent the underlying relationships that are separate from the surface manifestations of the language.
and so you're working on another book now. Does this focus on this question of truth?
That will be part of it, but mostly what my intention is to write a book that says if you want to go towards building artificial general intelligence, this is what you need to know.
Wow.
And it's hard to write a book, a textbook of something that doesn't exist, but that's my goal. This is what you need to know to build general intelligence.
Wow. We'll have you on to talk about that for sure. How does our audience, do you want our audience to contact you? I know you're busy.
LinkedIn is the best way. Find me on LinkedIn.
Okay.
Uh,
Well, on behalf of a grateful digital universe, Herb, thanks for who you are and for what you do, and most importantly, why you do it.
Thanks, Gary. It's always a pleasure talking with you.
Thank you. And to our audience, stay tuned for more from the Cyber Hero Adventure Show.